Okay, this unit test.
Oh, McDonald's, you were late, weren't you?
No, I wasn't.
Oh, I thought you were late.
You guys aren't here, so. This one is one of the most insanely difficult tests that there are in this class. So, here we go. So where does the instantaneous rate of change equal the average rate of change? So that's find the instantaneous rate of change and the average rate of change. How do you find the average rate of change? F of 4 minus f of 2 over 4 minus 2. What's f of 4? 64 minus 24 is 40 minus f of 2, 8 minus, is it 12? Negative 4 over 2. Well, it's 44 over 2, which is 22. Okay, what's the instantaneous rate of change? Okay, well, f of x, or the first derivative of x, is equal to 3x squared plus 6. So you set 3x squared plus 6 equal to 22. Move the 6 over. 3x squared equals 16. Divide by 3. X squared equals 16 thirds. Take the square root. And it's 4 over the square root of 3. Okay, or 4 square root of 3 over 3.
How many questions are on this?
Like 23. How many values satisfy the mean value theorem on here between negative 2 and 3? Okay, the mean value theorem basically says the slope is this. How many other lines have a slope of that? Well, there's one here that would have a slope, one tangent line to this that would have a slope, one tangent line right here that would have that same slope. Any others? What about right here? There's a tangent line there that would have that slope, right? Anytime where it curves down or up, it would have that same slope as this one. So, how many values satisfy this? 3 values satisfy that. Okay? That satisfy the mean value theorem. The average value is the same along there. Okay? So those were some not very nice ones. This one I think is an easy one. Okay? Where is the second derivative less than the first derivative less than the function, if this is a function? Well, what is the second derivative test? Concave up or down. So that has to be basically almost a negative number. That's less than this, which is less than this, and this is slope. So where is it concave down? Slope is either negative or 0 and having a positive number. So where is it concave down? Slope positive or 0, and then be a positive number. C. C is concave down. The slope is 0, and it's a positive 1 as a value. Okay? All right. So where is the second derivative greater than 0 here? Where is the second derivative greater than 0? A. Because it's concave up there. Okay? B, the second derivative would be 0. Okay? Where is the first derivative equal to 0? It's both at A and C. So if they want one answer, the answer would be A. That fits both of these. Okay? Because A, it looks to be horizontal for the slope, and the second derivative is a positive number. Okay? All right. Where is this function decreasing? Okay, how do we find where a function is decreasing? Find the first derivative, which would be 2 times 1/2 is 1. X minus 6 has to be less than 0. So x minus 6 has to be less than 0. So x has to be less than 6 in this case. So it should be from negative infinity to 6. If we want to test that, okay, we can put like a negative, or let's just put 0 in here. If we put 0 into the first derivative, we get a negative number, right? And a negative number for the first derivative gives us a negative slope. Okay, so from negative infinity to 6, the function is decreasing. How many mins and maxes would this function have if this is the first derivative of the function? Okay, you got to be careful when you take the test because you got to look if it's the original function or if it's a first derivative function. Well, this is a first derivative function. Hello. I've got one. Somebody's got to swing in and grab it because I'm in the middle of teaching. But yeah. Yep, sounds good. No, not right now. Yep, bye. Okay, how many mins and maxes does this function have? Well, where are mins and maxes located at when you see a first derivative graph? When it crosses the x-axis. So if you have a function that goes from negative to positive, it's going down for a slope, and then it's going up for a slope. What is this point? Whoa, what just happened? So if it's going down then up, what is this point called? That would be a min. That would be a minimum. Here, the slope is positive, and then it goes negative. So here it would be a maximum. And here it would be a minimum. Okay, you need to understand that kind of logic when you take the test. Find the absolute max and the absolute min in this situation. Okay, so between -1 and 3, where's the absolute max, where's the absolute min? So let's find the first derivative of this function. First derivative function would be 3x squared plus 12x. Okay, set that equal to 0. Solve it. Take out a 3x, and you get x plus 4 equals 0. So you got to check the points 0 and -4, right? Do you have to check -4? No, why not? Not within our range. So you have to check these 3. So you stick -1 into the original function. You get -1 plus 6, which is 5, plus 14, which is 19. Stick in 0. You get 14. Stick in 3. 3 cubed is 27. 6 times 9 is 54. 54 plus 27 is 81. Plus 14 is 95, right? So this would be the absolute max. And this would be the absolute min in this function. So it's coming down and then going up. If this is the first derivative of the function, where is a point of inflection at? Where does it change concavity? Okay, where does it change concavity? Where are the points of inflection? Okay, so for this is the first derivative graph. Okay, so what's happening here is there's a max, no, negative to positive. There's a min right here and a max right here. What do you think happens in between a max and a min? Probably a point of inflection. Now, looking at this graph, where in the heck do you think a point of inflection would occur? It is 2. That would be a point of inflection, and also 4 would be a point of inflection, because where it changes slope, okay, where the first derivative changes slope would be where the second derivative equals 0. And where the second derivative equals 0 is a point of inflection. Understand the basic logic behind there? Yeah. So this would be a point of inflection, and this would be a point of inflection. Okay. Okay, this is a second derivative function. This is a second derivative function. Where would the point of inflection be on the second derivative? Where? These are all points of inflection. These are all points of inflection. So, it's concave up from negative infinity to negative 2 and 0 to 2 because they're positive. When the second derivative is positive, it's concave up. When the second derivative is negative, it's concave down. So negative 2 to 0 and 2 to 8. Okay? So, concave down here and here, concave up here and here. Where is this increasing, decreasing, concave up, concave down? Okay. So, there's original function. The first derivative of this function is what? 40x cubed minus 5x to the fourth. What's the second derivative?
120x squared minus 20x cubed.
Set them both equal to 0. So this one, if you factor out 5x to the third, you get 8 minus x. This one, if you factor out 20x squared, you get 6 minus x, correct? So 0 and 8 are mins and maxes, and 0 and 6 are points of inflection. So how does that work? Well, if we make a little chart, so then from negative infinity to 0, something's happening. At 0, something's happening. From 0 to 6, something's happening. At 6, something's happening. At 6 to 8, something's happening. At 8, something's happening. And from 8 to infinity, something's happening. Okay, lots of things going on. So, from negative infinity to 0, what's a number that's in between negative infinity and 0? Easy number. Negative 1. So if we stick negative 1 into this function right here, into the first derivative, we get a negative minus a number, a positive, which makes it a negative. So this will be negative, so it's decreasing right here. If you stick a negative 1 into this function, you get a positive 120 plus another 20, so it's concave up. It's decreasing and concave up. We're going to skip over 0 for right now. From 0 to 6, what's an easy number? 1. Stick 1 into this, we get a positive. Stick a 1 into this, we get a positive. So it's increasing, and it's still concave up. Okay? We'll skip over 6 for now. 6 should be a point of inflection. Okay, from 6 to 8, the easiest number is probably 7. So it's 7. Oh, I don't know. You're going to have to help me, calculator. Somebody with one. Anybody have one out? In math class and nobody has a calculator out? I suppose. 343 times 40 minus 5 times 7 to the 4th. I think it's going to be a positive number, but I'm not sure. I think it's a positive.
Yeah, it's 1,715.
It's a positive slope. If we put a 7 in here, take 120 times 49 minus 20 times 343. Now this, I think it's negative, so I think it's concave down. Right? Oh, nobody checked? Okay, just trust me. All right. And then if we stick in a 10, 10 cubed is 1,000 times 40 is 40,000. 10 to the 4th is 10,000 times 5 is 50,000, so it's negative. So this is negative. If we stick a 10 in here, we get 100 times 120, which is 12,000. And then 10 cubed is 1,000 times 20 is 20,000. So 12,000 minus 25, 20,000 is negative. I don't know if I did that right. Stick a 10 in here. 120 times 10 squared minus 20 times 10 cubed.
Negative 8,000.
Really? Why did this change concavity? Oh, it's okay. Yeah, it's concave down. Yeah, it's a negative number, right?
Yeah.
Come on, Bierschbach, think. Okay. So we got where it's decreasing and where it's what its concavity is. Now, if you look at the points in between, if it changes from decreasing to increasing, it's either going to be a min or it's going to be an asymptote. Can we have an asymptote with this? Are we going to divide by 0 anywhere? No, so this must be a min. Here, this is a point of inflection because it changes concavity, but the slope is decreasing, I guess, increasing slope, and then back to decreasing slope. So increasing, so it's not a min or max. But here, it goes from increasing slope to decreasing slope, so this must be a max. Okay, so that's how you use derivatives to test. Okay, what's happening at 0, 1, 2, and 3 given the data below? Okay, so at x equals 0, our first derivative is positive and our second derivative is negative. What's happening? Well, it's increasing slope and concave down. What's happening at 1? What's my slope? 0. So it's probably a max and it's concave down. Slope is negative 2, so it's decreasing for the slope and it's point of inflection. And at 3, it's decreasing slope and concave up. Okay, so you'll need to evaluate you'll need to evaluate what's going on and see from there. A piece of cardboard is 10 by 10. What are the dimensions of the box that has the maximum volume, and what is the maximum volume? So it's a box with a lid. So you're going to basically cut off a corner here, and fold up this side. Okay, so that makes the side of the box. So you're going to have to do that along this side as well. And somewhere in here, you're going to have to cut off a corner so that the lid, this folds up and this folds up, so this folds up. So this would be the lid, and this would be the base, and then these would be the sides. Okay? So X and X, X and X, and X, because we don't know how big these are. So we just make them all X's. We don't know how much we're going to cut off to fold up. Okay, so those are all our heights. Because if we draw the box, our heights are X. Okay, so what's the base of the box now? Well, it was 10 all the way across, but we subtracted how many X's? Well, we subtracted an X here and an X here, so that's 10 minus 2X. And then the base is not only the bottom, but the top, so it's divided by 2, because there are 2 parts, okay? So the one base would be 5 minus X. The other side is, it's 10 long, and we took off an X and an X, so it's 10 minus 2X for this side. So to get the volume of the box, it's X times 5 minus X times 10 minus 2X. So you FOIL. And so 5 times 10 is 50. Outers is negative 10X, inners is negative 10X, so minus 20X plus 2X squared. And then distribute. So it's 50X minus 20X squared plus 2X cubed. Okay, so that's the volume function. We want to find where the volume is a maximum, so we take the first derivative of the volume. First derivative of the volume would be 50 minus 40x minus 6x squared. So set that, what? Plus 6x squared. Thank you, Miles. Set the first derivative equals 0, and that's where the maximum should happen. Okay? I don't know if that factors. You can take out a 2. So it's 2 times 3x squared minus 20x plus 25. Don't know if that factors. So doing the quadratic formula quick, negative b plus or minus the square root of b squared minus 4ac all over 2a. 4 times 3 is 12. 12 times 25 is what? 300, right?
Yes.
So it's 20 plus or minus the square root of 100 over 6, which is 20 plus 10 over 6, or 20 minus 10 over 6. 20 plus 10 is 30 over 6, which is 5. If x was 5, could you have the box? If we cut off 5 off this edge and 5 off this edge, would that be a box? Because this side is 10. If you cut 5 off from each side, wouldn't be a box. So that is not an answer. So if that's not an answer, this has to be an answer. So when x equals 10/6, or 2 and 2 2/3. Yeah, 2 2/3. So when x is 2 2/3, so what are the dimensions of the box? Well, if x is 2 2/3, this is 2 2/3 for the height. 5 minus 2 2/3 would be 2 1/3. Yep. And then 2 times 2 2/3 would be 4 4/3, or 5 1/3. So 10 minus 5 1/3 would be 4 2/3. And you multiply them together to find the maximum volume. Okay? Fun. By the way, Whitney took how long on her test? An hour and 45 minutes about on this test this morning. Poor Whitney. But she didn't get a review, so it really sucked for her.
Oh
All right, a store is going to fence off an area in the parking lot, like, Runnings has their building here, and they'll fence off an area so they can put like a garden area in here. They want to use 100 feet of fencing, and they want to make this as big as possible. What should their dimensions be to make it as big as possible? Well, since the building is right here, okay, since the building's right here, then they don't have to use any fence here. So you have a width and a length, okay? They have 100 feet of fencing. So your perimeter equals 2 widths plus a length. So 100 equals 2 widths plus a length. So your length would equal 100 minus 2 width, right? The area, you want a maximum area, so the area is the length times the width. So if your area is the length times the width, yep, then, yep, you're welcome. Good luck today. So 100 minus 2w times w is your area. So your area would be 100w minus 2w squared. So if you take the first derivative of that, it'd be 100 minus 4w. If you set the first derivative equal to 0, w equals 25. So your width would be 25, and your length would be 50, because you have 100 total. Okay, so 25 times 50 would be your maximum dimensions. And so your maximum area of 25 times 50, whatever that is, 12,500 square feet. Okay. Given x squared plus y squared equals 25, what's the slope and concavity at this point? Okay, so how do you do that? Well, you have to take the first derivative to find the slope. What's the first derivative? 2x plus 2y dy dx equals 0. So if you solve for dy dx, 2y dy dx equals negative 2x. dy dx equals, if we divide by 2y, we get negative x over y. Okay? So if we stick in a 3 and a 4, dy dx as your slope, you get negative 3 over 4. So the slope at this, so the slope is negative at that point, because you get a negative 3/4 for your slope, because you stick the numbers in for x and y. Now we got to take the second derivative of this to find the concavity. What's the second derivative? Well, the second derivative equals y times the first derivative of negative x, which is negative 1, minus x minus a negative x, minus the numerator times the first derivative of the denominator, which is dy dx, all over y squared. Okay, quotient rule. So if we go plus a positive here, and we put in the dy dx, we get negative y plus x times negative x over y, all over y squared. So it's negative y plus negative x squared over y squared. If we stick in the 3 and the 4, we get negative 4 plus, yeah, thank you. Just stick it there. Okay. So then it's a negative and then 3 squared over 4 squared. So it's negative 4 minus 9/4 over 16, which is going to be a negative number, right? So it's concave down.